Okay, so we're going to continue now by looking at the related questions under preparation of gases. Okay, so the first question under preparation of gases here is question 9. Question 9. Now, question 9 says, you have a diagram. So the diagram we provided, it says there is an A part of the question. It says, what is observed when the following tests are performed in the laboratory? I. Hydrogen gas is passed over heated copper 2 oxide. Passed over heated copper 2 oxide. And then II. A piece of colored cloth is lowered in a test tube containing chlorine. And then III. Carbon 4 oxide gas is passed through lime water for a long time. Okay, so we have question A. If you, for instance, if the question says when hydrogen gas is passed over heated copper 2 oxide, if you react hydrogen gas with copper 2 oxide is CuO. You're going to form copper and then water. Okay, so water will be formed. So, and water, this water is actually will be in a gaseous form. So water vapor will be formed. So in the process, there will be an evolution of water vapor. So water vapor will be formed. So water vapor will evolve. Okay. Now, when a piece of colored cloth is lowered in a test tube containing chlorine. When I was talking about test for chlorine, I told you that chlorine is a bleaching agent. So when you introduce a litmus paper into a chlorine gas, the litmus paper become bleached. So it's the same thing here. When a piece of colored cloth is lowered into a test tube containing chlorine, the colored cloth will become bleach. So there will be bleaching. Hey, this one is water vapor. Sorry, water vapor. Okay, so for II, when a colored cloth is put into a test tube containing chlorine, there will be bleaching of the cloth. So there will be bleaching. There will be bleaching of the cloth. Then II, carbon 4 oxide gas is passed through lime water for a long time. I said that in testing for carbon dioxide, you use lime water. So if the carbon dioxide is passed through the lime water will tell me, okay. So that will be the observation. So the lime water will turn murky. Okay, so that is for the A. Now the B part. It says the setup below is for preparation of a certain gas in the laboratory. So you have the diagram and some parts have been labeled as I up to VI. The question I says name the parts indicated in the diagram. So I. You're supposed to name the parts. So I, IV, V, and then VI. So the part labeled I is a Thistle funnel. I is a tripod stand. I is the gas jar, or as I said, gas cylinder. The IV is conical flask. So when I was explaining, we didn't come across that flask. This one is conical flask. Conical flask. And then the V. The V is the delivery tube. And then the VI is the cork. Okay, so these are the labeled parts. These are the labeled parts. And then VII. VI says what method is being used to collect the gas? What method is being used to collect the gas? If you look at the diagram, the delivery tube is pointing downwards. So I told you that method of collection is downward delivery. So downward. Or as I said, downward delivery is the same as upward displacement of air. Upward displacement of air. Okay. Then III says name two gases which can be collected by the method named in II above. So you are naming two gases that can be collected by downward delivery. I told you gases collected by downward delivery are gases that are more denser than air. So you have oxygen gas, you have carbon dioxide gas. You have hydrogen chloride gas. You also have chlorine gas. So all these are gases that are more denser than air, and so they are collected by downward delivery. And the IV is saying that how can the presence of each of the gases named in II be tested for in the laboratory? So the test for each of these gases, I've given you the information. It is on the WhatsApp page. So I'm just going to talk about the first two. Test for O2 gas. What it means that the two, yeah, so I've listed four. It means that the two that you list, you should know how to test for them because of the IV. So how do you test for O2? Test for O2. That's So that's how it tests for oxygen gas. You introduce the flames of a glowing splint into a test tube containing the gas. If the glowing splint rekindles, then it shows that the gas is oxygen gas. And then test for carbon dioxide. In testing for carbon dioxide, the gas is introduced or bubbled through a test tube containing lime water. Okay, so in testing for carbon dioxide, you bubble the gas through a test tube containing lime water. And then when the lime water turns smoky, it shows that the gas is carbon dioxide. Okay, so that is for the test of the first two gases. So that is for question 9. That is all for question 9. Quickly, we're going to look at question 10. Quickly going to look at question 10. Okay, so quickly going to look at question 10. Okay, for question 10, it says the following apparatus is for the laboratory preparation of oxygen. So here the gas being prepared has been stated. You are preparing oxygen gas. Okay, so A says name the part labeled I, and IV. And then B, write down the names of the chemicals used in the part labeled IV. C, how would you test for the presence of oxygen produced? Okay, so for A, we are labeling the part I to IV. From the diagram, the part labeled I, that is the gas jar. But if you look at this, the gas jar being turned upside down. So you don't just label it as gas jar. As I said, you label it as inverted gas jar. Then your II is the basin or the trough. So basin. And then your III is the delivery tube. And then the last part to label is the IV. Your IV is a test tube, but this test tube is being heated. So if you write just test tube, if a test tube is heated with strong heat, it will end up breaking. So this one, you have to indicate as a hard test tube, or it's a Paris. Paris. The Paris is hard. So Paris test tube. Okay, so those are the label parts. And the B, question B says, write down the names of the chemicals used in the part labeled IV. You'll be informed that you are preparing oxygen gas. I told you there are two ways of preparing oxygen gas. Either you use hydrogen peroxide or you use potassium chlorate. Potassium chlorate. Okay, I told you that if the reagent you are using is hydrogen peroxide, then the setup will involve what? A tester funnel, where the hydrogen peroxide will be in a tester funnel, and then you have the catalyst, that is the manganese 4 oxide in the flat bottom flask. But this diagram does not contain that kind of setup. There is no tester funnel. There is no flat bottom flask to contain the MnO2. So it means that this setup involves the KClO3 with the MnO2 as well, the catalyst. So the chemicals there will be the potassium chlorate and then the MnO2. So you have potassium potassium chlorate. Let me write the IUPAC name here. So potassium triiodochlorate 5. That's the KClO3. And then you have manganese 4 oxide. That's MnO2. Okay, so these are the chemicals. And the C is asking to test. It says, how do you test for the presence of oxygen gas produced? So in the previous question, I talked about that. To test for oxygen gas, you introduce the flames of a glowing splint into the test tube containing the gas. If the glowing splint rekindles, then it shows that the gas is oxygen gas. Okay, so when you introduce the glowing splint into the test tube containing the gas, if the glowing splint rekindles, then it shows that the gas is oxygen gas. The gas is oxygen gas. Okay, so that is how it tests for oxygen gas in the laboratory. Okay, we're going to end today's class by looking at question 11. Going to end today's class by looking at question 11. Question 11a. It says the setup below is used to test for a gas in the laboratory. And then I is asking to label the part I and II. So for A, I, we labeling the part I and then the part II. And the part labeled I is the cork. Is the cork, and the part labeled II is the delivery tube. Okay, now II, it says name the gas that is being tested for. Name the gas that is being tested for. And then the II say write a balance equation for the reaction producing the gas. So I told you that for you to identify the gas that is being produced, you have to look at the reactant. From the diagram, the compounds that are reacting there is sodium hydrogen carbonate and dilute HCl. And I told you that whenever you have a carbonate, a compound that contains CO3 reacting with an acid, the gas that we produce is what? Carbon dioxide. So for II, the gas being tested for is carbon dioxide gas. So we have carbon. And then the III says you should write the balance equation. So we have the sodium hydrogen carbonate reacting with the dilute HCl. And you have sodium chloride plus H2O plus CO2. So that will be the balance equation. So the Na combined with that, H combines with the form A2CO2, A2CO3. I told you this compound is not stable. So it breaks down to 4 H2O and then CO2. Okay. So the balance equation is NaHCO3 plus HCl, giving you sodium chloride, NaCl plus H2O plus CO2. Then IV says, what are you likely to observe in the test tube containing lime water? So the gas produces CO2. In testing for CO2, I say we make use of lime water. And when the CO2 is passed through the lime water will turn milky. So yeah. the lime water will turn murky. The lime water will turn murky. Okay, so that concludes for question 11A. 11A. We're going to look at the B part. The B part. The B says a gas evolved when a mixture of calcium oxide and some crystals of ammonium chloride were heated in a test tube. You are supposed to name the gas, give two physical properties of the gas, and also write a balanced equation for the reaction that took place. I advise that for you to name the gas, it will be better for you to write down the equation. And then from the equation, you'll be able to identify the gas that will be formed. So we have question D. I. The II, which is for you to list the properties. And then we have the III, asking you to write the equation. So you're going to write the equation first. Equation is calcium oxide plus ammonium chloride. So in this, the calcium combined with that, you have calcium chloride. The ammonium combines with this, with the oxygen, and you form ammonia gas and then water. You have water and then NH3. Okay, so in balancing, chlorine here is 2, but here is 1, so you put 2 here. If you do that, the N is 2, so you also can put 2 here. Okay. Now cross-checking, calcium is 1, oxygen is 1, oxygen is 1, nitrogen is 2, nitrogen is 2, hydrogen here is 8, hydrogen here is 2, plus 6, making 8. So that makes the equation balanced. So from here, the gas that is produced is ammonia gas. So the I, it says, the I is asking to name the gas. So the gas is ammonia gas. And the II says, give two physical properties of the gas named. So you're looking at two properties of ammonia gas. So I told you the ammonia gas is odorless. It has it is colorless. It has no color. So it is colorless. But then it has an odor. I told you specifically it has a urine-like smell. So it has a urine-like smell. It has a urine-like smell. Okay, or as a sense of being specific, you can just say it has a choking smell. It has a pungent smell. I told you the ammonia gas is also what? A basic gas. It is a basic gas. It is a basic gas. Okay. Now, when I was talking about the properties, I talked about the fact that some of the gases are acidic and then some are basic. If a gas is acidic, what it means is that it will turn blue litmus paper red. And then if it is a basic gas, it means that it will turn red litmus paper blue. So here, you can write that it is a basic gas, or you can say it turns a red litmus paper blue. So that is another property. It turns red litmus paper blue. In terms of density too, I told you that ammonia and hydrogen gas are collected by upward delivery because they are less denser than air. So So you can also write that. So it is less dense than air. It is less denser than air. Okay, so these are some properties of this ammonia gas, please, not ammonia. Ammonia gas. So some properties of ammonia gas are this: it is colorless, it has a urine-like smell, it is less denser than air, and hence red litmus paper blue. Why? Because it is a basic gas. Okay, so that ends question 11. And that also brings us to the end of today's session. Please, the information that I've posted on the WhatsApp page, if you have not downloaded it, go and get access to it. It provides the necessary information on all the gases, the setup for their preparation, their properties, their tests, and their uses. Okay, so please go download them and make sure you go through them and try the remaining questions under preparation of gases from question 12 up to question 18. God willing, in our next session, we're going to continue from question 12. But I expect you to try your hands on them even before we meet in the next section. Please remember to stay home and stay safe. And make sure you also spend quality time to study. Until we meet again, God richly bless you. Bye-bye.